Ooh, hello. Hello, you. Ah, come off. Come on. Come off. Come on. Such technology. We live in a world of wonder. So let's try that again. I've kicked my router. And back in this game. I say game, it's not. It's Universe Sandbox 2, I think it's called. And it's almost kind of not cocked up, but it's I've kind of started off in a weird place, so I'm going to try to put it back to how it was by boosting the time. Ah, there we go. That's kind of how it looks normally, where it's running in a faster simulation. So it's a simulation sandbox. Hello, Andrew. Hello, Sorab. It's nice of you to join. And it's a kind of lazy Saturday because we've just had the village fete and had a hot dog and sticky bun. And I want to settle down with learning something new. So I downloaded this game using a bit of spare birthday money. Most of it, in fact all of it, kindly given to me by Jared Rebo, the multi-rotor guy. And I've spent some of that on StarCraft Bridge Crew. And I spent the rest of it now on this because I think it was on offer. It's pretty cheap though anyway. And this is a sandbox. It's really just a game for messing around and simulating. It's not a game at all actually. It's just a simulation. And you can just do apparently experiments, but it doesn't just reside with sort of Newtonian physics models and things like that within our own solar system, but it can also be used to simulate galaxies smashing into everything. So Andrew's saying Star Trek Bridge Crew, not StarCraft Bridge Crew. Did I say StarCraft Bridge Crew? That'd be weird. I quite like that idea. You could play some Zerg. So let's see. I've not done any tutorials with this. It does come with a lot of tutorials, but I'm just having a quick play right now. So if you click on a body, a celestial body, you can see that you have this little thing that pops up on the right, and that's all of its information, telling you the mass, radius, density, age, all these things. And this is all like kind of really worldy stuff as far as I know. I think it's meant to be a super accurate kind of simulation of these things. Kieran's saying you hate black purple. I don't know what purple is, but I certainly don't. So yeah, let's have a look now. So here's the Earth, and what you can do, of course, is let's just have a little bit of housekeeping here. You can actually have a look at the like the planet here, and you can slow it down by using these adjusters here on the bottom. So you can slow that right down, and then you can get basically a 1 second to 1 second match between the simulation and the real world. So that is going to be pretty much, you can set the date and time. Let's see, this is in 2040. Time zone, local. We'll have to play with that to figure it out, but you can actually set the exact time. So it's the universe, life universe, the everything at the exact time it is right now. Let's just do some having a look here. Just looking at the controls here on my other monitor. So Andrew Dalton saying, isn't the rotational speed of the Earth something like 64,000 miles per hour? It might well be. I mean, it doesn't look like it's going around very fast now, but it's all relative. So if you look, take one part here. So there's Africa. Let's go to the light part here. Okay, so it's easier to see now. So let's, I don't even know what we're looking at. Okay, so this is like Argentina, this is North America. So if I leave the mouse cursor here, I mean, look how fast it is actually moving real fast from this perspective. So you could work out on the map what's the difference between this bit and this bit, which I guess is some part of Mexico or something, or Peru, I really don't know. Show my ignorance here. Or is that Africa? Hang on a minute. If that's Africa, is that Europe? See, I'm really confused now. Anyway, but if I hold the mouse cursor, you can just see how it glides past so quickly. I mean, that's cutting through thousands of miles. So I think Andrew's probably right because, yeah, it's whizzing by. And then if you zoom out here, you can just kind of see where that is in relation to everything else, which is bonkers sauce. Because if you think when you launch a rocket from something like Earth to Mars, it's not about where it is now. You don't fire it along my mouse line here to get to there. You fire it where it's going to be at some point in the future while Mars is still moving. And you can, what's really cool is I put the speed up, you can actually kind of see it a bit more. I'm just going to be putting a bit more. I'm just going to keep nudging this up because I'm not sure. There we go. Look at that. As you can see here, Earth is whizzing away much further, much faster than Mars, of course, because it's closer to the Sun. So it's got a shorter. If you imagine a kind of a cord going from the Sun to the Earth, it's shorter. It's whizzing around. And then you're going to have really odd things. So we see everything in a sort of two-dimensional plane, but now if you turn this over, you'll see. Sorry, just shut the door. There's a bit of noise here. You'll see that the solar system, of course, is kind of slightly more three-dimensional. It's also, of course, there you go. I'm going to center this to the Sun, by the way, because at the moment we were doing everything in relation to the Earth, which is kind of crazy how they used to think. So yeah, everything's kind of moving in this plane, but there are other things that are not quite moving with it. So I'm trying to see if we can find one of those bodies. So here's something here. You can have a look, see what that is. Zoom in. Ah, I thought I had it selected. Maybe not. Okay, see something. I've double clicked on something. Oh, there's Haumea. Let's go to Haumea. Haumea is a dwarf planet, so we can at least find that one. And you can see that took some zooming, and it's spinning around like mad. Let's get some specs for Haumea. So these dwarf planets, though, they're the ones that they didn't think were really planets. And I'm not sure if Haumea is actually bigger than Pluto at this point. So something I noticed a moment ago when my stream kind of cocked up, but if you can see in the top left, there's loads of pre-done stuff here that you can open and tutorials and things like that. So if I do open, I found this one here. Look at this, Tesla Roadster in space, and then there's a description of what that is. And I'm going to close that because it's underneath the chat window. But if I zoom in, keep zooming. There it is. Look how cute is that. And what you can start to do then is if you zoom back out again, hello, you keep zooming out. I'm getting I've got a visitor. One moment, please. Yes.
I was in the toilet.
I'll come in and give you a present. What you can see is there's Mars. And where did we lose our Tesla Roadster? There's the Tesla Roadster. We can try to you see that line, you can see its track here, and they did say in the papers that the Tesla Roadster was going to miss Mars. So if we put the speed up again a touch, you can set it all in motion. So it didn't really leave Earth at a massively high velocity, and I guess if you think about it, you'd have to be giving it some serious boost to really push it, or send it off at another angle. I can't remember. I think once it got up out into Earth orbit, they were doing some messing around with it before they eventually pushed it off. So maybe they didn't have a massive amount of fuel. But what you can do is, if you plot this, now they said it would get close to Mars, but not actually get to Mars, and you can see that here. You see, it's actually going to miss, which is a shame. And I guess that's. They obviously must have known that was going to happen. And there you go. See, it missed it. And I've been watching this for a while, and they never meet. Oh, close. No, I say close. I mean, close is probably like a gazillion miles. And I'm sure there are some tools. Let's see if we can get this to sort of go close again. And that may well be have been its only chance in like a million years. Remember that you got to be kind of careful with this sort of thing. You don't break your mind. I'm just gonna see. Might be better to rewind. Hang on. No. All right. Let's assume that looks pretty close, but obviously it's not. Is there a way of measuring? Reverse time, reverse velocities. Now I don't see it here, but clearly there must be. Okay. This is just a model of the smaller model of the universe they used to show the Tesla. But look at these are the planets actually in order of mass, aren't they? What else? Let's see what else they've got. It's like they've bundled up all the planets here and actually they're crashing. Because the rings... Look, see there? Uranus's rings are hitting Jupiter. I can hear a knocking on my door and it's incessant. It's getting louder, louder. Knocking, 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 knocking. Give me 2 minutes, guys. Yes. Go on. We're gonna eat a lot of peaches. Okay. Right, we're sort of exploring still. Do they honour the warranty if you take it into space? Yeah, probably not. Collisions. I like the sound of that. Collisions. Boom! Hang on, I'd like to see that again. I think they did that a bit too quick, didn't they? Can we go backwards if we... No. Oh, right. Probably ought to learn how to actually reload. So the moon has impacted the Earth, and the Earth looks like it's pretty molten and unhappy about that. Something's happening to the planet. Looks like the whole planet has pretty much gone on fire because of that. And it's hot. Surface temperature 3,879 degrees C. Now let's speed up the time because it's only like 16 minutes per second. So that was real quick what we just saw. Surface temperature is still the same, 3,879 degrees. So I wonder how long it will take to cool down. So it's 1.3 years per second. And you can see the temperature is starting to cool down now. 3,800, only cooling by a degree. It's approximately maybe a degree a year. Right, 50... Oh, 240 years per second. It's recovered. It's recovered. Oh there, look, but the surface temperature now is minus 197 degrees. So it took like 3 millennia almost to recover, and then it just sort of went downhill from there. So yeah, I wouldn't advise that. It would be best to avoid having our planet collide with the moon. People are obviously into collisions because they're sort of colliding all sorts. And this is that same collision, it says in slow motion, so you can really see what's going on. That's insane, isn't it? Also, the moon looks a lot bigger than you'd expect, I think. To be honest, if that happens, I don't think you saw that whole thing occurred in just a few seconds, right? Right, so that's we're 6 minutes in. So whoever's, to be honest, as soon as that's touched, you're gonna. At the speed that moon was travelling, though, if you think about it, 6 minutes from just touching the edge of the Earth to like fully in it, we're inbound. And I'm just going to have a quick look before we move on to another thing, just to see how long does it take for that wave to hit the other side. Bang. Within an hour, that's it. Everything's gone. 1 hour. 1 whole hour. Just a few. I'd like to think that there's some surviving astronauts, but I'm pretty sure they'll all be gone as well. You saw how much material was fired out around the orbit of the planet. So let's have another look, see what else you have. You've got all sorts of things. Wolf and Earth. What is Wolf? Oh, is that Wolf 359? There you go. Red dwarf star. Was that one of the Star Treks had a battle of Wolf at 359? Maybe. Made it a bit bigger though, didn't it? Andrew Dot says that would be an ELE, pronounced ILI, extinction level event. Wolf 359 was the big Borg battle. Well, I'm pretty sure the Borg wouldn't have even been able to throw Earth into a sun, but they'd give it a damn good try. They'd have to have really decided they're not going to be doing any assimilation that day. So Sun and Jupiter. In this simulation, 100 Jupiters crash directly in the Sun in a row. The added mass causes the Sun to go supernova. Hello. I mean, that sounds pretty awesome. So I'm just trying to get away. I want to see the mass of the Sun. So the mass is 300... And, oh, hang on. What am I clicking to? Okay, so it's become Jupiter. Is that absorbing the Sun now? It says 61 Jupiters. What are we looking at here? I think we almost have to restart this simulation just to see what's going on. Yes, please. Right, so that's the Sun. Does it go supernova that quickly? 404 Jupiters the Sun is now. 42 Jupiters. 43.2 Jupiters. The Sun's looking a bit big. Surface temperature 10,000 degrees C. Boom. See, it goes up. It sort of cools down and goes up. So these are like, it's almost like an engine where the Sun is basically being like hit with these things. Let's speed it up a bit. It looks like though, can those Jupiters even catch up with it now? And that Sun is out of here. Come on, go! If you look actually at the Sun there, you can see at the back. You see there? That's the sort of wave from the explosion of Jupiter just carrying through. I don't think at this point whatever you do... Oh, the sun's gone, has it? It's cooled down. There we go. So much fun, this. I mean, I don't know really much about it, you know, planetary physics or something, but it's just curious, isn't it? What does 5 moons hitting the Earth look like? Oh, it put a bit of top spin on it. It's like a space version of billiards. Beautiful. Now, if you look along the top though, there's a lot of kind of sort of serious sounding things here though, to do with like physics, explosions, stuff to do with the solar system, like here, now and in real time, planets, and there's really cool ones, exoplanets, fiction, human scale stuff, and galaxies. So we'll have a good, we'll have a play through some of those in a moment. But I think it's just interesting. Just have a quick look at some of these basic ones in this core menu. So here's one called Galaxy Collision. And Fairfight 14 says it looks like some crashing into each other further back in the line. Yeah, it maybe some of those Jupiters started to go backwards or something, like the whole, those balls, executive stress relief ball things. So, about 4 million years from now, our Milky Way galaxy will collide with a nearby Andromeda galaxy. This collision, the result of mutual gravitational attraction between the stars, planets and other matter make up both galaxies, will produce a single merged galaxy. It is unlikely that any stars in the galaxies will actually collide, although some stars will be ejected from the combined galaxy during the merge. That's it, Andrew, and Newton's cradle. Isn't that amazing? It's an amazing and beautiful thing. I kind of feel if you're on the bridge of Star Trek, this is the sort of thing that Picard and Riker would probably be interested in going, having a little visit and having a look. Amazing stuff. And if you look at the time scale, this is like 64 million years has elapsed now. 64 million years. It's a whole different scale on the old clock there. Saturn with rings. Let's have a look at the old Saturn. Look at that. It's amazing. So it's got this detail of just Saturn alone. It doesn't matter, like a microscopic, macroscopic level. No matter where you go, you're going to find stuff. Just repeating over and over. It's like Saturn is its own solar system to its own gas and clusters and stuff. The same way that Earth is like a solar system to all our satellites and the moon. And the moon. Oh, floating fat man. What happens if the Earth's orbit is if the moon is knocked out of orbit into deep space, like Space 1999? Gosh, I hope there is that scenario here. Should I just type that in? Space 19. No. This moon. Let's look at scenarios involving the moon. Or, alternatively, we've got solar system here. I think I saw one which said system. Oh, it's because I have moon in here, perhaps. Hang on. Let me get. Yeah, I had it in a filter. Earth and 50 colliding moons. Yeah, there's a lot of dicking around stuff here. Now. I just want the solar system. Earth solar system. Here we go. In this simulation, 22 moons of varying size are randomly placed around the Earth. Yeah, well, I don't think that's quite what we've got right now. I need a realistic solar system. Let's watch this briefly. Are they going to crash? Because what it shows me, though, is that we might have potential for just ejecting our own moon. If I can just go back to basics, please. New and empty simulation. Add. Oh, here we go. Earth. There we go. One's enough, thank you. Do I have to add the moon? I am the moon. Just trying to do a little search thing. Where's the search? Oh, there we go. Now, I've no idea though what's the distance from the Earth to the bloody moon. Or does it just work it out by itself? I feel though, for this to be a valid simulation, we have to just go for the regular solar system. I don't think. Yeah, I don't understand these things. Look at these. Several people just doing random solar systems. What's the point of a random solar system? I want the actual solar system. How do we get back to that? Core. Earth and moon. Right. Finally, I found what we want. We want the actual. Here we go. The actual solar system. Now, can anyone remember from Space 90? Hiya, Becky. Floating Fat Man. What happens to the Earth here? Dot says, then we have crazy adventures. Well, that's the idea. That's what I'm trying to do. Get our crazy adventures going. And the bloody Tesla Roadster's still there. You can see that just in the distance. But let's go to Earth now. And yeah, Becky knows all about this stuff, being an expert in it, in the field. So there's the Earth. So we don't know what time and space. We could put in the year in the bottom left corner when the Earth. Oh, it was in 1999, doesn't it? So we'd have to sort of set the time. Space. 1999. Close enough. Oh, I don't think it's letting me go back in time right now. Well, let's pretend. I think we're close enough here because it just goes round and round. So there's the moon, and we're gonna try to see how do we fire it off now in some amazing way. Tools, force. What am I seeing here? It's doing this random flickering. Force settings, equivalent mass, mid-range, right-range, inner angle, outer time zone. Okay, what's a pulse? Oh, it tells you. Apply a cone-shaped force extending outwards from the cursor's position. Explode the selected body. I like the idea of this. More of a launch though, wasn't it, really? Blubber-lipped Martin Landau. And Andrew says that Tesla's got 8 billion miles and still can't find the charging port. Also, Andrew, I got some ribs left. Oh yeah, so good. Right. Andrew, tell the people in the chat about these ribs. They're so good. They need to have them. Right, I'm just going to see if I can apply some sort of this force cone. It's crazy. Look how. Oh, is it? I'm just adjusting the time. No, I thought it's sort of freaking out because it's something to do with like the time setting being wrong, but it doesn't seem to be doing anything with it. I mean, it's funny to think it would. This is bound to be tricky to use, isn't it? Because it's doing something tricky. Material. I'd just be happy if any of these tools did something. Launch a stream of particles of a set material. Material. Iron. Velocity. 1,000 kilometers a second. 100 particles per second at 10 degrees. Yeah, okay, that sounds pretty good. Oh, I don't think... Are we running? Yeah. Oh, hang on. Let's speed up the simulation now. Go get 'em, boys! Not sure if that's affecting the moon too much. Let's bring up its data, see if it has any sort of effect on it. Name, mass, radius, density, age, surface temperature, speed. Escape velocity. So particles certainly don't seem to work. Oh, so Becky's saying the speed of light is 299,792. 299,792 kilometers per second. So yeah, Andrew's ribs were a mixture of 6 different spices and herb blends smoked for 12 hours, low and slow. They were damn good, I have to say. They are damn good. I'm bored now, let's just blow up the moon. Blown it up to hell. I don't think it's going to affect the old Earth in any way whatsoever. So clearly nobody's been nerdy enough to come up with a Space 1999 projection. However, they obviously are nerdy enough though to play with planets and their gravity field. Look at this. I'm just expecting any time to the simulation to break down here. Yeah, it's all going to be Pete Tong. But if we speed this up, what happens eventually? Do they coalesce? No, look, some just going off forever. I suspect the physics model will break down, in terms of resolution. So even something that's sort of quite predictable. So if you can imagine a sinusoidal wave that you'd have in a game, like Monty on the Run, when the enemies are going up and down, very predictable. The simulation runs through this set of numbers. But this is on a whole different level. If I speed up the simulation, it's going to take broader steps in its mathematical calculations, and that will create small errors, rounding errors. And those rounding errors will get bigger and bigger, and you'll see weird stuff happening. So I suspect if you watch this long enough, it'll probably balance in the state of equilibrium, and that'll be fine. But if you then make it really fast, I think they'll probably... Yeah, look, there you go. Awesome, right? Awesome. So Andrew wants to see if anybody's drawn a big cock and balls. That's kind of cockish. Yeah, I think that's good job. Add some tools. How do we do fireworks? No. Ah. Okay, that's pretty cool. Does slow it down some, mind. We are. The old simulation is creaking along. Fiction. The ultimate engineered solar system. Yeah, give Gary a weekend, he'll get it done. I think that's Gary's challenge. This is the ultimate engineered solar system. It's a nice colour. It's got a nice warming glow. Let's have a look how it's ultimate engineered. Oh wow, so it's got actually a lot of planets which have names. We'll centre in on one of those. And they're the equivalent mass of 40 moons. 40 of your Earth moons. I've just noticed something here as well. We have our chat box that kind of covers the data box, so that's no good, is it? That's no good. You should mention something. 40 of your Earth moons, human. Are all the planets in the green zone? Yeah, they are. But I'm not sure what the rainbow effect means, if it's temperature or something. They are rather organised, which is great. What else have you got? Lands of Ice and Fire. Game of Thrones. Game of Thrones. The planet Westeros, as described in the A Song of Ice and Fire series by George R.R. Martin, experiences unusual weather patterns. Winters or summers can last for years, but their severity and duration are impossible to predict. A group of astronomers released a paper on April Fool's Day suggesting Westeros may orbit a binary star system. The complex gravitational interaction system would cause the planet's distance to the central star to vary, creating variations in surface temperature of the planet that would be impossible for the Westerosi to predict. So let's see what they've done here. So this is a binary star. So that's two stars, like two suns. And you can see that's your planet Westeros floating around. We're going to spin it up so we get to see its kind of ellipse a bit clearer. But we should see it's kind of a wonky ellipse. Yeah, and it kind of is. Maybe that's all you need. Well, if you think about it, you wouldn't need too much variation. Otherwise, the weathers would be crazy. It would be crazy. But it looks circular enough. Circular enough. Groovy stuff. Let's see what else the sort of nerds have done. Thread worlds. 5 planets. What did it say? 5 planets share one orbit. So you've got the 5 planets there going around. I suppose that's pretty neat, but how would your universe, your solar system actually manage to actually achieve that? I think they all have to have the same mass, so let's check. So that's 1 Earth. 1 Earth. 1 Earth. Yeah, they've all got a 1 Earth mass. Otherwise, let's have a play then. Let's see if we can do this. So this is planet 2, and we're going to see if we can change its mass. Yes, we can. Let's make it 2 Earths. We're going to cock it all up. We are. Do we need to speed up? It's messed it up, but it could still exist there, right? Let's do more like 10 Earths then. Yeah, you'd expect more, right? So, clearly, I don't know anything about the solar system. Becky said she likes exploring with Space Engine. It's a beautiful program. I don't know what Space Engine is, but does it sound similar to this? Nomad. A rogue black hole passes through the solar system, threatening life on Earth. So there's a black hole. Look at that. It's got the mass of 40 suns. What does it look like? Ah, look at that. It looks exactly like that movie. Remember Interstellar said it would look. Because they said, what is a hole in 2D, 2 dimensions look like? You know, a hole is just a circle. Yeah? But what is a circle? What's the representation of a circle in a 3D space? A sphere. So that's it. The black hole is like a kind of inverse sphere. So it's like a mirror. It's similar, but you can't play snooker with planets. Well, planet snooker is while we're here, of course. So I wonder if we will start finding something. So see these human-sized objects. A variety of human-created objects, real imagined, lined up in order of size for comparison. So Becky, are we saying that this simulation is so realistic we should be able to actually play actual snooker if somebody came up with a billiards table model and then put the balls in and we just sort of could hit them around, a bit like that episode of Red Dwarf? I'm trying to think, what have they got here? They've got all manner of things. So there's like a Doctor Who. Let's see if can I move. Can I WAS? You can. WASD works. Nice. So we can go through all this. So there's various dice, billiard balls, football, pumpkins, as you expect. A mirror tetrahedron, which I don't think could be any size, surely, but that's fine. It's beautiful. It's like the thing from 2001. Just the guys, you know. The phone box from Doctor Who. What's that? Is that the Cassini or one of those things? Or is that the Cassini? That's the Cassini. Voyager 2. See, these things are pretty friggin' used. You've got the Tesla Roadster there. You go, yeah, that's interesting. But then look at these. When you talk about launching satellites, you're not talking about launching something that's like a, you know, fit in a suitcase. You're talking about things that are just huge, like a friggin' bus. Third stage of Saturn V, the Juno reactor. Is that it? Or do they have bigger things? What's this thing here? There's something there. There's an object for sure. Is that a pyramid? Haha. The Great Pyramid of Giza. And look there, there's the spaceship from Arrival. I like that. Is that what we've got? Yeah, that's everything. Look at this though. This 3D engine is great. Look how it's just throwing this stuff around. I suppose it's not many polygons really, if you consider it's not a it's not a rendered starfield. So Andrew's saying technically the TARDIS is the biggest thing there. Yeah, I guess the TARDIS is, because it's kind of got that infinite size thing going on. To die. Okay, good. So this is a really nice example of mutual gravitational attraction. Look, they formed one bigger die. Okay, so they obviously are treated as planets, so they kind of suck into each other. But this is the idea, of course, that if you have objects in space, right? Let's just say they're positioned a meter apart without any vectors on them at all. Nothing's touching them. They will just start to move towards each other. And I think that attraction rate is proportional to their mass. Because, Becky, correct me if I'm wrong, is gravity not related to mass? Because the objects are kind of like warping space-time. And then that's causing them to fall into each other. I'll leave that with you while I have a look through the options we have here. A supernova in a galaxy. Sounds exciting, doesn't it? I'm not really sure if it is. So Becky says it's proportional to their density. What's the difference between mass and density for us at home? Us noobs. I think density and volume. Density and volume would define the mass. Sun nova, something it just spat it out. Is that enough for you? And away it goes. We're talking 21 million years so far. Can't really imagine that. Oh, mass is volume in dimensional space. There we go. I feel we've all learnt something, and that something is we don't know what we're talking about. Not you, Becky. I'm talking about me. Dark matter. It's not very dark though. It's red. I'm guessing they've highlighted it for our viewing benefit. So it says here, the simulation can't run any faster with the current settings. So, who would have thunk it that my computer cannot simulate the entire galaxy at real time? Well, actually, faster than real time at 6 million years per second. Experiments. So Becky's saying 1 cubic meter of steam is much less dense than 1 cubic meter of iron. Yep, we got that. Mark Hume says, has anyone watched Steins Gate? No, I didn't even know he had a gate, to be honest. in a field. Planet grid rocky. So let's see. It's probably just some sort of nice little, almost like periodic tables of planets lined up for you. Maybe you could just use these for cutting and pasting into your own designs. I don't know if they're genuine. They probably are, you know. Maybe if you select them, you can see where they live. Not really. Ooh. Materials. Oh, okay. Let's go back to the solar system and see what happens if we make the Earth out of something else. Come on. Core. Just regular one, please. Regular solar system. Saying, however, if they're both affected by a gravitational force in a vacuum, they'll be attracted to the source at the same speed. Got you. Okay. Interesting. Interesting. Unfortunately, I think I'd need several lifetimes to be able to study all the things I wish I could study. And now I'm almost at that age where studying has become difficult for me. I think that there's probably billionaires there, or millionaires, or people who don't have to work, who squander their wealth in not being able to re-educate themselves and learn about new things and become true scholars. That's the irony of life, isn't it? Right, so there's the Earth. And what we're going to do, we're going to bring up its panel, but we're actually going to zoom out so we can kind of get that track. Because I want to see kind of what it does. Let's try to get it a bit faster now. I want to get it. It says I can't. It can't run any faster. Oh, it's strange how I'm getting to these sort of limitations now. Before we were zipping this stuff around. Oh, so you set a target. So I've set a target for 200 years per second, but it's only managing 3. Probably because the model is too big. It's probably kind of the entire... yeah, look, it's the entire thing. Because I saw an Eris there, and I don't even know what an Eris is. So let's do the Tesla one. I think the Tesla's a bit more of a dumbed down one for us. Yeah, okay. So we got this zooming around, and we're going to click the Earth. Go away. We're going to click the Earth, but I kind of want to select the Sun as the perspective. Let's see how we can do that. Yeah, we can do that. And then we're going to speed this up a bit so we can just see things moving around. Yeah, so this is a simplified universe, or solar system rather. So we're going to play with the material composition of the Earth. And Becky's saying, yeah, I'd have loved to have learned electronics when my brain was still young and hard to learn at my age, 32. So I think we're similar age, and you know, we could do a knowledge swap, and I'm sure if we met in a social context, we could teach each other and learn a little bit, but it would only ever be now scratching the conceptual surface of those subjects. I can watch any documentary, I promise you, on the universe, galaxy things, and I can totally 100% understand it. And Stephen Hawking's, when you're reading the books, I can totally 100% understand it at that instant that I'm watching or reading it. Because I don't have to put that into practice. I don't have to put this into practice in my day job in any way, sense or form. So those interconnects in your brain for using that knowledge are not there. So it's a shame. It's a shame though, but it's nice to be able to understand stuff, or when there's a bit of maths or calculus on the screen, you can figure it out and go, yeah, I get that. But putting it into something that can be executable, very difficult. Right, so we've got the Earth's whizzing around here, and it's currently this 24.7% iron and 75.3% silicate. And 0.02 is a tiny percent of water. So the planet Earth, there's hardly any water at all whatsoever. Mainly hydrogen, as is the entire... hang on, I'm thinking, am I wrong? Is it hydrogen or helium? No, hydrogen. The galaxy is pretty much hydrogen, if I think by volume. Becky, tell us please in the chat, by volume and by mass, what is the most abundant elements, and I think there are two different elements for this. I don't think it's both hydrogen, but I would love to know the answer. And I think that'll be good enough for the ultimate question for us watching along and at home. So I'm going to click along the solids. I'm moving up from that about 27%. Let's go to 50%. I just want to see if there's any discernible change. You can see the Earth is getting closer. You see this inner track here. Its vector is pulling in closer. So what that means is after this runs a few times, it will start to follow a different path, and that will be that inner path. I'm pretty sure of it. It's just getting drawn into the sun now. But we're going to have to speed it up to see those changes. So eventually that line will close, I'm sure. So let's try to make... Oh, I like this cutaway. Look at the top right corner. You get a cutaway of the planet showing it. That's how they're making this model. So if you make it like, let's say it's 100% now. We're a ball of iron. I wonder what that does to our mass. Although if you see here, it says cumulative properties, though. We are still only one Earth. So I don't think what's going on there. Ah, there's something here called the mass loss total. You see at the bottom? So it means it's calculating all of these things relative. I'm going to have to learn a little bit more how it's playing with these. So Becky's saying the most abundant element in the universe, it's hydrogen, although 99% of the universe is dark matter. I guess we don't know what it is because it's too dark. We can't figure that out. So I'm kind of disappointed we weren't able to affect things here from when we're playing with the planet here. Doesn't seem to do much for us. Like we've got the radius. I mean, we could try making the radius bigger. I mean, what if we just literally double the radius of the Earth? Radius. That just hang on. It did not like that. There's probably a limit here. No, that's kind of the maximum. So maybe it just is what it is. You can only play with it a little bit here. Becky's saying it's unknown because it's not emitting any radiation, hence the word dark. So is a black hole a dark matter? I mean, a black hole is pretty much, I'm guessing, only visible by that sort of lensing effect you described earlier. Ooh, there was some interesting slider action going on here. Stuff to do with all its orbital thingamajigs. Now, I can't remember. I was speaking to a very interesting chap, and he was telling me there's a program that calculates all this. And it might have been the one that Becky was talking about that you can buy. It's a package that if you work for a space company, that just does all of this for you, and you say I'm here and I want to be there on Mars. When will it get there? And it'll tell you like the vectors and the thrust and the payload and do all the calculations. It's all like off-the-shelf software now for space. It's unbelievable. I would have never believed it in a million years we'd get that point. But yeah, it's like all of this stuff you can get. But I imagine a seat of that license is going to be something crazy expensive. Stress tests. Oh, so these are tests that actually test the simulator and your software. So my PC may well crash. And Becky says a black hole emits particles at the speed of light out of its polar point. Oh, okay. So I guess if one of its ends are pointing at you, you'll see something. And Fairfight14 says, yet people used to calculate it on a bit of paper. Yeah, indeed. It's unbelievable, isn't it? But I guess there's two ways of looking at it. I think in like near Earth orbit, yeah, there's a lot of maths. I think when you're firing out something to a planet, I think you really do need to have a certain amount of fuel on board for course corrections and minor alterations. And if you're firing a rocket to, say, Mars, or the moon for that matter, I think you're getting it to the vicinity. And then as long as you're more or less in the ballpark, yes, you don't overshoot it, you're pretty much there within its orbit. I'm sure you apply some thrust and get yourself where you want to be. I'm not sure if you can pinpoint to the exact second you're going to arrive and where you're going to land on that surface. I don't think you can, and I suspect that's probably how they could do a lot of this as pen and paper maths. It's kind of good enough. But I agree. I imagine there's probably some differential equations here that work out these planets. There's probably a set of maths ready for this. And I'm stuck, by the way. It's not that I'm just gassing with nothing on the screen. The system is really taking its time. I think it's loading up all of these planets for this stress test. So let's see what happens when that happens. But it does give you an interesting sense of scale, doesn't it? That how really we are quite insignificant in this, in the whole proportions of our not just solar system, but galaxy and universe as a whole. And if we want to really get going as a species, we need to start getting our Star Trek on, right? And start building us some spaceships and technologies. And hopefully prove our earlier science incorrect, or earlier theories incorrect, and discover ways of technically getting faster than light travel. And I like the idea that despite all of the massive amounts of energy required to do so, and I'm sure, you know, physicists would argue this, that a lot of these things are impossible, but there may be ways of manipulating the fabric here of the universe to allow us to achieve a seemingly faster than light travel. You see what I mean? You're not breaking the laws, you're just bending them. The same way when you have a compressed data in a zip file, and you think, how are you getting smaller than 8 bits per byte compression? It doesn't make sense. How can you get 0.1 bits per byte? Well, you're not really getting that. You're achieving it by just turning the data, manipulating the data through a transform. And I'm hoping maybe there's something we can do here on this. So Mark Hume saying dark matter could be emitting radiation, but in a form or spectrum we cannot detect. I think that sounds good. Yeah, that sounds possible. Fairfight40 says, I like watching Cosmos, a space-time odyssey. Is Cosmos one of the sort of Carl Sagan books? I mean, that's something. I think I might have had Cosmos as a big book once. Becky says, possibly Mark, or it just decays before reaching us. Yeah, maybe it's all weak. And Mark Hume says, we need to stop all this conflict and pool our resources to spread humanity. And I'm just looking out the window to see what's the weather. Bad weather, so I agree. We need to pull our resources to solve this weather. Now, I don't know if any of you have been listening or reading, I think they are in book form as well, the audiobook of the Bobiverse, that Jared Rebo put that onto me. And it's a really great book, and there's some spoiler alert, but not much. You'll read this on the blurb, but effectively a sentient satellite, or sentient satellites, get launched from the Earth to do stuff from humans with pretty suspect motives, to be honest with you. But fortunately they kind of, I might have to reboot this. It looks totally dead before it kills my whole computer. It has. And what they do, they basically fly off and are doing all sorts of fun and japes. But if you imagine a sentient satellite, it has to figure out things like resource gathering. It has some sort of 3D fabrication on board. It has some sort of 3D printers, and it can make circuits, it can make mechanisms, has limited materials, it doesn't have any weaponry. And it's kind of left to defend itself in the universe, in the immediate solar system. And I think they do go quite far in the end, because they obviously are sentient satellite. They live forever. But it sort of kind of shows you a view of humanity, that if you really want to send humanity further out afield, it may well be in the form of our AIs. Our AIs will be our representatives. Maybe our biological beings will never get very far. but AIs that carry our sort of ethos and mentality and things will. And what's interesting about that is that if you have different people launching these and different people creating these AIs, they'll have totally different perspectives. So you can imagine there's lots of people on Earth right now who like fighting each other or don't quite have the same viewpoints of each other. So imagine all of those people launching their own AIs. They're almost representatives of Earth. So yeah, that's sort of some food for thought. But if you like kind of reasonably hard sci-fi, I think you'll really like those. And I was speaking to somebody yesterday about the David Weber books. The David Weber books, which is the Honor Harrington series, and they're really good if you like epic space battles with really nice, pretty hard sci-fi on how the ships work, and it's really cool. Like the ships are kind of, I think they're more like this shape actually. I have something that's a bit more like this shape. They're kind of cones, a bit like, you know, Rendezvous with Rama. Shit, coffee everywhere. And should have shut the lid on that one. And basically they've got these I'm going to put this down, it's leaking all over the place. These things called impeller wedges, and it's kind of just describes how the energy beam pattern comes off the ship so that they can be pushed through the fabric of space as it's described in those books. But what's wonderful about it, they kind of have armaments. So they've got broadsides. So you have these long tubes, and when there's space battles, ships of the line, you know, they're obviously going side by side to give each other broadsides, you know, from the sides. But they've got these impeller wedges, which are their drives. Because the drives basically are capable of warping the fabric of space, they're pretty much impenetrable by any electromagnetic or weaponry. So if I turn my ship on sideways so the drive is facing you, or the edge of the impeller wedge, you can't attack me. So these ships have these amazing sort of battle formations, and they're all in the books, all of the tonnage, the energy and engines, the weaponry systems, how it all works. And when they're having their broadside battles, where they're basically rotating like this, because they're basically covering their impeller wedges to protect while their armaments are being reloaded, and then when they face you, bang, 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 bang. Really cool, because then it's a 3D battle. How do you destroy this ship? Well, it's 3D. You start attacking them on the ends and stuff like that. So if you love that kind of book, again, David Weber, look them up on a verse. Let's have a look here. Becky said, let's scroll back up. So Mark Hugh, whoa, let's go way back up. So Fairfight 14 says a reboot for a version of the show in the 70s. Yeah, I think it's Carl Sagan's Cosmos thing. I think it was a whole book and everything. Becky says, one large meteor and we could be wiped out. We could colonize Mars and increase our chance of surviving, which is exactly what Elon Musk is trying to do. That's his vision for humanity. At least that's what it currently is. And he says all of his Teslas and all of these companies and efforts are to drive technology or fund the technology. Oh shit, I just loaded another first test. Oh, that's a bit better. At least it works. To do that. Launching from the moon will be more efficient too, sure. Or launching from space itself. But I guess from the moon you can get the materials perhaps to make fuel or reaction mass. Fairfight 14, the problem is something could be coming towards speed. The impact would be fast the speed of light. I don't know if the speed could be faster than the speed of light, but it could be close to the speed of light. But I think the probability of it hitting us, you know, if you think of the idea of trying to thread the eye of a needle, and the needle is on the other side of the planet, and you're starting off on the other side of the planet, the Earth, with your vector, and your vector to line up to hit that piece of string through that needle is going to be pretty much non-existent, right? Now imagine the diameter of the Earth is probably like, you know, let's say the size of 20 solar systems or something. I think that's probably what the math will work out. Like, it's really unlikely unless someone's throwing it at us. And they've been really accurate in their prediction. Like I said, you've got that dead reckoning. We can do quite a lot from an almanac and mathematical calculation, but we can't quite predict it. And that, you know, maybe the fact that we can't quite predict it is a good thing, because it kind of shows that everything's not preordained in the universe and there's some random elements, and we're kind of maybe not running in a simulation. Or some of you might say, well, maybe we are running in a simulation because it's a rounding error. You shouldn't get rounding errors in real life. Yeah, and we can see the rounding errors when we run this type of simulation even in front of us. Ooh, deep stuff. So Becky's saying, fortunately, anything with considerable mass can't go at the speed of light. It would have more energy than the universe. Phew. Good for us. Mark keeps saying something like O'Neill cylinders. The lore of the Warhammer 40k universe is interesting too. So O'Neill cylinders. I wonder if that's a ship in something. I'll Google that later. God, I stink of coffee now. Spilled that on me. But yeah, I do like a bit of proper sci-fi, I have to say. I do like some light sci-fi from time to time, but I think the Hannah Harrington universe and the Ian M. Banks sort of culture universes, those two for me are the two I can live in. I like that. I respect those the most, really. They're the best fleshed out for me. Look at this. This is a bit jerkified. But I'm guessing, yes, look, every particle in this ring has actually got some proper mass. 40 grams. I'd have to turn up my PC to be a bit beefier, I think. Mark Humes saying Warhammer 40k universe is grimdark, though. It's Reet's grimdark. Great in VR. Well, I've not got the VR with me today, so I'm not going to be trying that out. So I'm just going to try maybe a couple of things, and then we're going to do something. There's that Nomad. I think, Becky, you mentioned Nomad again. Becky's saying we can't base our assumption on a simulated universe on our simulated knowledge and machines. Yeah, because of course, well, you've got no idea of what substrate we're running on and what's the limitations of that substrate. It's a bit like if you read We're Off to Be the Wizard. If you look at We're Off to Be the Wizard, that's quite interesting in that it's kind of about a bunch of geeks who find a computer file, which is almost like a universal computer file that's very terabytes big. So you'd load it on your Commodore 64 and you think, how can a file that's like 50 terabytes big exist on a Commodore 64? But you open it up and they discover it's you search for your own name in this file and you can see it's a real-time file describing your XY coordinates within this universe and your attributes and your things. So they're kind of finding a bit of the source code to themselves, and that's an interesting thing. And Beck said maybe the computer we're being simulated on is so far advanced it can do infinite recursion. Well, maybe, but I think what we're trying to do is we're trying to find the flaws to show us kind of at least some boundaries within that. Yeah, and I guess that's the other thing, really, that our other universes that we may even encounter one day, which we're not, but let's say we may, they might not even have any of the same physics that we have, which is exactly the same way as if we're running 2 copies of Universe Simulator in the same on the same PC, and through an API there's a memory share there, and there's lots of things like that because let's say this, Becky, there's these ideas, by the way, like where you have this quantum entanglement, so you're having information that's seemingly available in 2 different parts or everywhere at once, seemingly to be faster than the speed of light, because I'm wiggling something here and I'm bringing something is wiggling over here and seemingly happening faster at the speed of light because of the quantum measurements. You think, how can that happen? And there's always the idea that, well, it doesn't matter that they're here and here. The information can change instantaneously because on the substrate they're being simulated on, that memory address is actually down here, and it's a same memory address. It's a pointer in C. But our view on that universe is this, which is exhibiting that model, that limitation, that speed of light, you can't travel faster than the speed of light because of mass theory and all these things, but these particles are ignoring that because they don't give a shit about that, because they're obeying the laws of the substrate they're running on. So yeah, I kind of like those things. I like these are like thought experiments almost to try to describe things, and to be honest, they're almost just as valid a theory as any other scientific theory until they're proven wrong, and if they sound kind of plausible, then they're kind of worth thinking about and kicking around. Now, I don't want to get like shat on now by a million physicists saying, well, you don't know what you're talking about, shut up. which it's probably valid that they would do. But you know, I think it's healthy to think about these ideas, and it's for us. Computers and computing has helped a lot for us to actually at least give us a context for things we see in our... Look at this, is awesome. A context for things we see in our universe, because at least it gives us a shape to think about. So if you think of a brain, there's analogies within computing in the brain right away, right? Instantly. We can say, okay, so the brain is a bit like memory and a CPU, and it can do this and the other. And then we go, well, that doesn't quite work, by the way, because of this reason. And then we go, okay, fine. Then we change computers. We're going to define a neural network, an AI, backpropagation. We're going to take some ideas of how we can measure brains working and then make them back into computer simulation. So it's almost recursion that you can go back into that. And then we can use that computer to then work out what's brain thinking. And if you think about in the kind of Ian M. Banks universe, and they have AIs in that effectively called minds, which could be the size of a fridge, but they're almost like hyperdimensional. They don't exist necessarily in our space, so their mass, volume, vacuum, all those things exist in a different plane, so they are much bigger than the fridge. Yeah, but they're very clever beings. Are they beings, or they're just sentient life forms? Sentient AIs. They have their notion among themselves that if you're so advanced and you can predict a model, you can make a model of a planet or a person or a universe so accurately, right, that you can start predicting things and every movement of every particle or mass in that thing. You almost become like a mind reader in that you can actually predict the future at that point. And I think in the Ian M. Banks books they had a rule in that they would not delve too much into that because it didn't fit with their ethics, basically. You can so they could kind of manipulate societies and do things and all sorts of stuff. If you can just mess at that point, you're playing with this meat of the universe. You're this AI being, and you're just, oh no, object reference not set to an instance of object. Okay, broke that. Yeah, you're an AI playing with the meat of the universe, and that's kind of beneath you, really, because humanity are not their pets, but they're guardians of us. You know, imagine something so clever and so infinitely impossible. So let's have a look at the movies. Enterprise says, well, that's cool. And Becky's saying, I hope our universe doesn't crash the simulator. Well, it might crash it daily, and it might reboot exactly where it left off. So it's a bit like sleeping. Who's to say we're not running in a simulation? Every time you sleep, you are shut down, you die, and you're rebooted, and you wake up again. Consciousness itself could be something that's live simulatable, and then when consciousness ceases, you are turned off. How would you know? Why would you care? Do you care about the time before you were born? Should you care about the time after you die? Probably not. I'd maybe worry about your time on the planet and being nice to each other. That might help. So Fairfight14 says, with those as well, it seems that they changed before they were told to change as well. So that's the whole, again, looking at these weird quantum effects, and yeah, and your effects of measuring them. All sorts of weirdness there, and I think you need to listen to the Infinite Monkey Cage for those sorts of things. Becky says we should get Isaac Asimov's Ultravac computer on the subject. And the weird thing is, you're saying that, and I'm a big reader of Isaac Asimov, but I cannot for the life of me remember what the Ultravac computer is, because I've now read so many sci-fi books I cannot discern between each one. Let's look at those galaxies colliding again, because it was really awesome seeing that last time. The Milky Way, and is going to hit Andromeda. So Universe Reloaded sounds like a crappy Hollywood film. Andrew says, who's to say I'm not the only real person in this simulation, all fictional characters around me? Well, exactly. I could be a simulation, yeah, but I could be sentient within the simulation that I think I'm real. Andrew could also be projected in the same universe we are, but he could be actually a real life form real life forms consciousness also being projected in there. And Fairfight saying, what if your woken life is the dream? Yeah. And Becky saying, what if a massive computer designed to deal with every human need and problem? Oh, sorry, it was Ultravac. Well, I want to give you another thing, right? I remember reading something a while back, and I'll have to look at the mags. I do start throwing away the mags now because they kind of confuse. They confuse me. They can make a mess. But there was ideas actually that some of these quantum effects are at play in our mind, in our brains, and that's we operate at some degree at this level, right? We have these occurring for some reason, and that was extrapolated out to say, well, of course we are, because you need these little twiddly things going on in your brain that are, you know, twinned somewhere else in the substrate to basically operate to show that you're running in the simulation. And basically they're almost like waveguides for the RFID, the Wi-Fi signal of the universe. We are tapped into the universe because consciousness and our operation and our thought could just be elsewhere. It could be somewhere, I guess I say, in the substrate of the universe, and it's like, well, okay, fantastic. I think it'd be amazing if we could discover that was. You know, you zap something here and someone just goes unconscious because it's broken the link, and you turn it off and they kind of wake up again as these sort of snap back into entanglement, and you could prove that. And would it make a difference to know that you are the drone buzzing around, and your AI pilot is somewhere else, and Andrew is sitting somewhere else, being executed in a matrix? Not really, because, you know, I think therefore I am. I'm still my own consciousness, and I choose my path in my simulation. I choose what to think. I can't control what people do to me or do to the environment around me that affects me, but I can choose I can decide how I choose to react to it and think about it. So I guess we are still alive. It would be amazing to discover these things, because it would just explain more about our universe to us. So Ultravac sounds like a crappy Hoover being sold on the shopping channel. It does. And sounds like a baby Miss Piggy. You're a figment of my imagination. I seem to remember her saying that in the cartoon in the 80s. Maywell, that she did. Look at these dudes. I just got to show you this. Oh, look at these guys here. Beautiful. Bobbing around, bobbing along, bobbing along. Can't find the plane though where they're orbiting each other. That might be a job for when you're using your WASD keys to really start. VR, you need some VR for this. At least you can see him a bit doing that. Ultravac computed the heat depth of the universe and cleans those dusty carpets. So I think that's been a bit of fun. I kind of probably ought to go away now and dwell in a dark room on my place in the universe, or go and bloody start filming that pile of mail that I've got, that I sort of tweeted about this morning, but never got to yet. And I want to explain a little bit about my tweet before signing off, because a lot of people were probably surprised at being unfollowed. I've basically culled at least 2/3 of the followers I was following, which was a cull of probably 10% of the followers I was following before that. I'm probably down to probably under 60 now. And I want to say though, if I've unfollowed you, it's not because I don't find you interesting or I don't want to be your friend, because that's the way Twitter likes to make it seem, right? If you're playing by Twitter's walled garden rules. And they make it very hard for you to unfollow without it being a social interaction or someone feeling hurt by that, but don't in this case. I'm not playing by Twitter's rules at the moment. I don't like the way my timeline gets filled with any old junk that Twitter wants to push to me as an ad. I don't like where I have weird kind of, they're not bot accounts, but they're things that just retweet infinite junk into my timeline, and it stops me being able to enjoy and interact with people I really want to interact with. It's not so bad being tagged into something that blows up, that okay, because when I want to look in the mentions, I have to I get all of the blown up junk, and then there's the little message that says, "Hi Andrew, I want help with something." I'm missing that. So I've basically said what I'm doing is I'm unfollowing everybody, and there's a few people I haven't, because Twitter's the only way they contact me right now, because some people only use Twitter, but you know, that's fine, they don't tweet too much. But because I wanted to basically show that if I had like 0 followers, or very few followers, that it's not expected that I will catch what you're saying or what you're doing in my timeline, because I had too many people do that, and they'd say, "Andrew, didn't you see that?" And it's like, no, it makes you say, okay, if Andrew wants to see it, you have to tag him in, or mention me directly by tweet. Just say, at Back Office Joe, how you doing? I've got this thing, have a look. Yeah, do you see what I mean? It's a different way of interacting, because it's really hard if it's small social groups, like a Land Rover club or something, and there's like 50 of us in it. I'm pretty sure we'd love to keep in touch and understand what we're all about all the time. But if it's like 1,000 people, or 3,000 people, or 10,000, it's like you lose that personal thing, and I don't want that. I don't want to lose that. And that's why Discord's been really good for that, and we've got the Discord going where we can just keep up those conversations. So I'm going for quality, not quantity. So if you follow someone on LinkedIn, I think Andrew Dalton, we were talking about LinkedIn, that if they say they are a business guy, hi, I'm a business guy, and they have more than, say, 300 connections, having more than 300 is like the same as having 0. Yeah, because you cannot maintain quality relationships, be it business or personal or otherwise, with, damn it, more than 50 people, more than 30 people. Honestly, if you think of how many friends you have in your life when you become an adult, when you are in business relationships, I think genuine ones will probably be a similar number, maybe double at best. Yeah. So once people get to sort of 500 or 5,000, it's like they're just collecting Pokemon at that point. You don't need to be on their list. You're not following them. Gotta catch 'em all, Pokemon. So yeah, and the other thing as well, if I kind of say I'm not following people, then they won't take offence when I don't follow them, because I do get quite a lot of, "Hi Andrew, can you follow me for this?" or "Can you sub to my YouTube channel?" And it's like, I can, but it drowns then my YouTube feeds as well. It's like, if I know who you are, you're on my Discord, I'll catch your stuff. You can post your YouTube stuff in there, and we'll all look at that, and we're all friends together, right, with the same things. We're not going to get random posts from random people in random clubs who are into slightly different things. And I know it acts as someone said, it acts as a kind of an echo chamber for your own thoughts. It does, but I think when we're in the Discord, we're all here about the same things, into the same stuff, so that's fine. We're not, you know, I mean, it's you as the audience have the option of branching out and joining many other channels. I, as the subject matter, can stick to one subject, or my brief remit of subjects for you. Yeah, so that's fine. If I am a member of the audience, as I am, and I watch other people's YouTubes or Discords, other things, then I also do the same in turn. We'll join the Discord channels I'm interested in. You see what I mean? So it's not up to each other to broaden each other's horizons, as a rule. Yeah, we can do it. We can do it vicariously. Like, so if you're watching this stream and I'm talking about a book that you haven't read, and you go and read that book, and you go and you learn something about quantum entanglement because Becky said something clever, then that's great. It's passive. I haven't had to force it into your Twitter feed 2,000 times a day. Fair Fight saying, "I unique banning MIRC." I remember my unique banning MIRC. Right, guys, so I feel I'm kind of losing my voice a little bit, and it's been a horrible week of me being ill and a lot of travel. A lot of work done though, which is great, and it's great positivity, but horribly for me on the terms of not being able to speak to you. So it's been so good to be able to see you guys on the stream and chat a little bit, let you know about what I've been up to, and get my finger out on my big pile of stuff there. I'm surrounded by amazing, interesting stuff. I'm never bored. Don't worry about that. I'm never really truly bored. I just never truly motivated all the time. That's the problem. But I'm going to get back on that. And I'll see you on Discord and let you know what I've been up to in there as well. But have a fantastic Saturday evening. Go watch some junk on telly, eat some bad food, and chill out tomorrow. As ever, guys, thank you so much for watching. I'm really humbled by having you as an audience. All the best. Bye-bye. Stream ends. See you.